Hi, I'm Llewellyn Falco, and I'd like to start with a small demonstration of quantum mechanics. You can see that both of these talk titles are possible right now, and they actually are existing simultaneously. Of course, at some point I need to start this presentation, and one of these will end up being the actual talk title. So I was lucky enough to be invited on a beta of the first commercially viable quantum computer, D-Wave. You can see by the picture here the size of it, although a lot of that size is actually cooling, as quantum computing occurs at very low temperatures. And the reason quantum computing is interesting to programmers is for brute force combinatorics. Now, if we go through a little history of computing, we can start with the CPU, and this is one core. I have a picture here of a fabulous video from the Mythbusters showing a demonstration of painting a face with a paintball, one at a time. But soon we start to realize that by doing less robust computing, but many times over, we could do better things. This is that same demonstration for a GPU, with thousands of paintballs painting the Mona Lisa. So small programs, but thousands of cores. And I was trying to take this metaphor a little bit more, because if you had one core with the CPU and thousands of cores with the GPU, how do I handle a trillion cores? And I think you have to look at something like this. Quantum computing is a whole new world of very small programs happening at a whole bunch of times to get a single result. I'm going to take you through a small demonstration of prime factors. And the idea here is, what is the prime factor of a very large number? And this is a very hard thing for a CPU to do. It's going to take tons and tons of time. But a much easier question is to say, do two numbers multiplied together equal this number? And if you do that for all combinations of numbers, you will eventually find what the prime factors are. So let's do that demonstration, but let's do it at a smaller number that we can actually keep in our head. So we're going to look for the prime factors of 35, which of course are 5 and 7. We start out, we have 6 qubits here. The first 3 are going to represent our first number, and the second 3 are going to represent our second number. And when we are done, we're going to end up with the first one being 1, 0, 1, although in quantum computing we actually think of it as 1, negative 1, 1. And the second one being all ones. And this is a useful way for me to think of it as a programmer. But it's not actually a good way to think of it in the quantum mechanics. So let's sort of expand this out to what the full story is going to be. What we have here is every possible combination of the 6 bits. And you'll see that the energy probability of any of the other states has been massively reduced to 0. But we still have 2 highly probable situations over here and over here. So this one is going to be 5 and 7, and this one is going to be 7 and 5. And which one of those is actually going to come out when we touch it? Only God knows. So again, 128 qubits is the current computer the D-Wave is working on. It's a lot of cores. By the time we get to 300 qubits, we will actually be able to handle more cores than there are observable atoms in the universe. And how will this impact you as a programmer? Well, D-Wave is looking at platform as a service. And just to get an idea of what that might actually look at, it's worth noting that Jeff Bezos is a major investor in D-Wave. So you should expect that part of your Amazon services in the future are going to include the ability to run a quantum computing job at your will. Thanks for listening, and I hope there's a lot more quantum computing in your future.